Thank you very much for joining us, guys. I think the first port of call is let's do some introductions. So, Galina, if you'd like to introduce yourself.
Yes, hi. My name is Galina Pildush. I am a global senior consulting engineer working with Palo Alto Networks. Pleasure to be here.
Mikko.
Thank you, Sam. Mikko Karikytö, Chief Product Executive Officer for Ericsson. I've been with Ericsson 15 years and doing everything from incident response to hands-on penetration testing, and now leading the strategy and the implementation of security and privacy for everything that we sell. Perfect. Great to be here.
And Nagendra?
Hi, Nagendra Baikumpadi, Head of Product Security for Rakuten Symphony. I'm also the co-chair in ORAN Alliance Workgroup 11, which is working on security specifications for Open RAN networks. Thank you.
Cheers, guys. Thank you very much for joining us. I guess at this point, we'll dive straight in. And Galina, I think I'll ask you the first question, is how are advancements in artificial intelligence impacting the development of security over networks?
Thank you for the question. It's a great question. First, I would like to say that artificial intelligence, of course, as many of us know, is not new. It's been there for 40 years, approximately equal to. Words machine learning and AI are intermixed, but yeah. So without going into definitions, so artificial intelligence is being used already in hacking as well as in defense systems. And what is triggering the interest nowadays is that the speeds and the feeds and what 5G is promising to bring. So also the quantity of the connected devices. So we're dealing with IoTs, OTs. We're dealing with smart intelligent devices. How many of them are there? Each human can carry multiple devices, including embedded types of devices, like pacemakers, like other types of chipinized things. So hence, what comes with AI is, number one, any type of hacking really is not constant. The only thing that's constant in life is change, especially security. So when it comes to artificial intelligence, it is heavily used with MLs, of course, as to learning the behaviors that are proper. And then whenever the mutations come along, the mutations also contiguously change. So predictable analysis is a must. So yeah, did I say enough, or I can carry on for a week about this?
I feel it's very much a cat and mouse game. It's a bit like the Golden Gate Bridge in San Francisco. It's never finished. By the time you finish, you need to start again.
Yes. One other aspect I'd like to bring up is, for example, something simple like URLs, malicious URLs. Mm-hmm. They're not constant. So you might be redirected to a malicious URL, and then you're trying to investigate that. It's too late. So they contiguously change. So again, predictions as to what those things are is a key. And understanding at the points where you would like to provision or provide that security now, at all stages of attack kill chain is a must. So.
And with artificial intelligence, obviously, there's so much traffic now going over networks, especially, you look at what was 5 years ago and the exponential growth we've seen of that. Obviously, moving that towards artificial intelligence, the monitoring is a great way of automating it. But Mikko, how much can AI do in terms of automation for network security?
Well, firstly, I would not go and disagree with anything that Galina said. I think I fully agree with the complexity and the capabilities of AI. I think that I would like to zoom out on this question a little bit maybe and start from thinking about automation for security in the networks overall. So we just take a look into a telecommunication network overall. I claim that it's one of the most complex systems that humans have ever made. It is a system that is a nationwide, region-wide, so always alive, 99.999% of time it has to be serving the people, and it also is near real time and gigabit per second type of a system. There's no other system like that you can operate. So we have then at the same time gone from bare metal, rather simple still but complex to manage security system that was also quite proprietary.
Right.
So the protocols were telecom made and known only by the telecom people, and hackers had a limited ability to actually go and learn and then maybe hack and penetrate to the networks. Now we are shifting that completely. We are having common technology, we're opening it up. It's not only anymore cell phones connecting over the radio to the network, but it's actually all kinds of processes and devices and industries and enterprises that are dependent, and critical society services, for example. So actually, it's not question about how much or what can we automate. It is the question of there's no other way.
Yes.
There's absolutely no way for human to control this anymore. So everything needs to be automated in the security. Of course, there's going to be the AI assisted. Human needs to be making many of the decisions still. But I think that, for example, like we demonstrated in the hall too in our booth, we have the Ericsson Security Manager. That's exactly for the purpose that the biggest challenge in telecommunication is keeping this secure network going secure from day one. And that's exactly what things like ESM are addressing. So I think that we will be seeing automation in every stage of the life cycle of the network, and AI will have a great role in that.
Right.
Okay. You made a very interesting point about AI being necessary now. Nagendra, how much trust can we place in AI for network security? Is there a limit, or how far can it go?
But it's an interesting question. I think it's important to understand that AI is there to assist us.
Yes.
It's not going to replace humans. And therefore, I think whatever data that comes out of AI will be processed and handled by the humans. Now, the question is, how do we rely, or how reliable is the data that comes out of AI? To me, as a software engineer, I apply the same SDLC principles when it comes to preparing the AI system, whether it is during the planning phase or the build phase or the deployment phase or even the operation phase. So whatever you do that you typically do for securing your software, I think we have to apply the same principles to building an AI system as well. That is one way of building trust, right? And then of course, once the AI system is in place, it's operational. As Mikko said, you need to ensure that the system is secure, whether it is in terms of securing the training data, ensuring that the model itself is not contaminated, because there is a whole set of attacks that one can do. So I think it's we are still not there. I mean what we're talking about is mainly bits and pieces. But to me, at the end of the day, you build trust in AI by following the same process that you do for any life cycle of any system for that matter. And I think that is one way to build trust into your system.
Very interesting. Move on to another technology now. AI has been around for many decades. 5G has been around for 5 years. Obviously, with the advent of 5G 2019, we've seen exponential growth. Obviously, that's led to more data that's been, and more a bigger attack area, surface attack area for networks. So, Mikko, how has the rise of 5G impacted how Ericsson approaches network security?
Well, so firstly, we, of course, in Ericsson, we have a long history and heritage of building security and privacy in everything that we do since mid-90s and onwards. But I think that coming to 5G, and I have had the pleasure and privilege to be discussing 5G security with governments as well as customers and enterprises and all kinds of verticals. And I always say the same thing, that firstly, mobile telecommunication network is probably one of the most secure platforms to connect, period. 5G is the most secure generation in that path. So faster we can connect people, businesses, societies, services to 5G, the better. It will always be better to keep your phone connected to 5G and forget that hotel Wi-Fi. Just keep connected to 5G and you'll be much better off. So actually, 5G comes with very practical security improvements over the 4G. Again, that is already pretty secure. But I would say that the real changes are then that while we are enabling more and more different types of players digitalizing their business or their service or their society on this 5G network, we are at the same time also enabling them to be connected while them to be also attacked. So there needs to be a certain level of maturity built up and competence and knowledge being built up in the whole of the ecosystem. And of course, in the industry, we have a great responsibility. You mentioned, for example, the O-RAN Alliance and the specification work there in the security, so that the standards and specifications are secure, the products are secure, the deployment of the network, and then the operations are secure. And then we can make sure that actually those new services that are deploying on this technology actually have a good and very prosperous life forward.
Thank you. And obviously, when we talk about 5G, we can talk about the number of use cases over, 4G was a big leap over 3G, and now the 5G enables so many new use cases. Mikko, what about 6G? Is there anything we can talk about, even though we're a few years ahead? Is there any thoughts on security for 6G networks?
We have this tendency in the industry, and I guess outside the industry especially, to always look for the next G. When we've been talking, like I said, we're talking 5 more years about 5G, but I think that like I said, 5G is firstly the best performing and most secure connectivity platform there is. Every society that deploys 5G will benefit greatly. Just look at the innovation and growth that was created when we deployed 4G. Now we're deploying 5G. Let's look at the countries who have full-blown standalone 5G. Mm-hmm. Not so many there. So we have plenty of work to do. Actually, what have we connected? 1.6 billion people on the planet now on 5G. So that's a fraction of the whole population. So let's come back and talk 6G when we have 8 billion people on 5G.
Mm-hmm. Yeah, maybe I can.
I just want to add, if I may. So, with all due respect, in my mind, there is no such thing as 100% secure.
Absolutely not.
So with all the authentications and triple, quadruple crypto that we're doing in 5G, there is still this opportunity where UIs could be doing something they should not be doing. Mm. And when I say UIs, I'm also implying IoTs and OTs.
Absolutely.
So we as a company, Palo Alto Networks, and me personally, are very passionate and strong proponents of zero trust. Mm-hmm. And I know zero trust could be perceived as another buzzword, but in reality, when you dissect what that is, it is discussed in NIST documents very, very precisely. It is a methodology that says, I trust nothing. I always verify. I always verify before I encrypt, because compromised devices, for example, would be issuing signaling storms, and with speeds and feeds of 5G, you pretty much have killed the control elements, SBA, services-based architecture of 5G. Now, with containerized environment, you might argue this point and say, okay, if I have killed this SBA, I instantly roll up something, but even those elements need to be constantly verified. So patching, the good old patching that we all love, is a passé. It just simply won't work with the speeds of feeds. And I'm jumping into 6G question here. It's gonna get worse. It's as simple as that.
Love is a strong word.
Yeah. No, maybe I'll just spend a minute or two just to complement what Mikko and
Galina
had talked about. If you think about it, when we say 5G, or any G for that matter, it is coming from 3GPP, right? So they define these beautiful specifications. And as Mikko rightly said, from my experience, 5G has been the most secure set of specifications coming from 3GPP. However, I just want to bring in another angle. For the first time ever in 5G, the 5G core is service-based, it's cloud-based, right? So the operators who were earlier in a non-cloud environment, legacy environments, etc., for the very first time got exposed to the issues that one would face in a cloudified environment. I think, to me, as much as G has been evolving in terms of security, the first instance of the telco ecosystem getting exposed to cloud environment is through 5G. I think that's a big leap of faith that 3GPP has taken. And I might also add that in Open RAN, O-RAN Alliance, we are also implementing service-based architecture for RAN.
Yeah.
So I think it's going to be end-to-end cloud-based. So I think that's just one point which I wanted to mention.
Okay. We'll touch back on cloud in a bit, but I want to focus on a technology even further in the future now. If I could come to you, Galina. The conversation around post and pre-quantum using.
Right.
What does this
Another
mean?
favorite topic, yeah.
Yes.
Right, so post-quantum and pre-quantum. So we're in pre-quantum, although quantum computers do exist already today. IBM has, as an example, and some other companies also. But it's expensive. And Louise touched very, gave a good overview as to why do we need to be concerned about it. So 10 years, I'm seeing government is getting there sooner than anyone else. Maybe in another 5 years. 2030 will become a concern, but it is already a concern. Question is why? Well, what's happening right now is quantum computers will be able to decrypt asymmetric ciphers instantly. Instantly. So it's not hours. We're dealing with seconds, if that. So number one, the algorithms, asymmetry cannot be used as a cipher. So yes, many standards communities have created already algorithms that beat that Shor's problem that he proven that the formula algorithms that had proven that it's breakable. So now with that number also as to how long the keys could be and how long would it now take to decrypt is another thing. So some algorithms have already been, like RFC 8784 is been standardized. And what's happening is all communities, like entire community, is now implementing these to get everyone ready. Why? It's a process, how you get there. So in fact, in GSMA, a post-quantum task force group, I participate in this group. We've created, recently we just released the guidelines document, that's white paper number 3, where the process is discussed as to what needs to happen. Mm-hmm. With that, there are other things we need to worry about today.
Yeah.
So such things such as harvest now, decrypt later, is not a fiction, it's a reality. Mm-hmm. Data is data. Once I harvest what I harvest now, whenever I get my quantum little guy, I can do literally instantly decrypt sensitive information. So what is also very interesting is there are quantum ciphers that are not standardized and really shouldn't be used. Mm-hmm. And recognizing use of those, for example, within TLS 1.3 protocol, now is very, very important because that's not legitimate. Nobody can decrypt it. And why is this now encapsulated into this, funny tunnel, right? So these things must be looked upon and now, not tomorrow, now.
Interesting. Mikko and Nagrenda, do you have anything to add on quantum computing? Is this something that we, what preparation should we be making now based on Galina's comments?
Very good comments from Galina. I think it's easy to agree that we need to be focusing on crypto agility and then really post-quantum crypto. That's what we need to do, and we need to do it now. I would then maybe say that quantum key distribution is probably not something we need to discuss for the kind of commercial telco endpoint device use. Maybe that's for other uses, but not necessarily here.
Yeah, just to complement what Mikko, and by the way, good explanation. The NIST in US has already standardized 4 algorithms, 1 for key management and 3 for signature. I think that's a lovely step, right? Because now that it has been standardized, as Galina also mentioned, there are projects in place to implement them in common libraries that people use, like OpenSSL, for example. And I think it's all in the right direction. I think it's just a matter of time where vendors like us would start playing around with TLS 1.3 and see how it progresses. And by the way, I don't know how many of you noticed, on February 21st, Apple announced that the iMessage that we all use in our phones, it's going to be now enhanced for post-quantum cryptography. And I think that's, again, when big players start moving towards post-quantum cryptography, I think that will give a lot of onus and push for other players to also come in.
Comes as an indication for other companies that maybe they should start considering it as well. And Mikko, if I come to you about cloud technologies in telco, obviously we're seeing a big push from many operators to move to cloud now. It's been going on for a few years, but I'm seeing some real acceleration. What does that mean for security over the next couple of years?
So I would maybe, as a security practitioner, I would always love to see how when we shift from kind of technology scheme to another, that we meet completely new types of issues and we get inspired to solve them in new ways. Unfortunately, many times the same issues that were happening 25 years ago keep happening in modern systems as well. So
Fully agree with
yeah,
you.
exactly.
Yes.
So we're still talking about like passwords and the segregation of duties, segmentation of the networks, and all the kind of basic stuff, configuration management, backups, logging, etc. But when it comes to clouds, I think that some good points were made already about that it brings some kind of flexibility also. As an ex-incident responder, I would really love to have the capability that I don't need to fly on the other side of the planet to pick up hard disks to do forensics on them, but actually be able to pull down the CNF or microservice or an image of the infected machine and then replace them flexibly and dynamically with a fixed configuration with secure setup again into the cloud. And so those kind of things are really positive. I think that then like O-RAN Alliance and Open RAN overall was mentioned. So we look at from point of view that in Ericsson, everything needs to be built with the same security and privacy quality from the beginning, regardless what kind of technology you deploy it on. We are having synergies between the different technology generations so that we are having the same security in all the existing kind of hardware or the bare metal as well as the cloud version. But then also I would say that even that there is this talk that open cloud native generation of technologies opening for new threats, which is of course true, because you have a little bit different venues or avenues for attack introduced, but at the same time, like Senthil made the presentation in the beginning, I think that they have 14 billion reasons to believe that open cloud native networks will be the future. So it's really here to stay.
Okay. And Galina, if with the cloud services,
Which services, sorry?
cloud services. If they're opening up cloud services, you got the hybrid, the public cloud, the private cloud.
Right.
What does this mean for security? Is it going to open up the attack area? Open up to third-party developers? Where does the
so the word open scares me as a security person.
Yeah.
So, listen, the word open is being trialed at since decade ago, where some service provider wanted to, and I'm going to go back out of security into routing, were trying to build their own BGP demons, if you will, right, to do BGP routing, as opposed to let it put on bare metal machines and run and see. So let's step back. A cloud, no cloud, is just another POP in my mind. So whether or not that point of presence is owned by an operator or by a hyperscaler, right, should be, to me, it's orthogonal when I talk about security. So it does not matter where this is geographically, the same security principles must be applied, right? So, and then question is, what are those security principles, right? I go back to my ZTA situation, zero trust architecture. So to define zero trust architecture, what it should be, I need to identify what the flows are. I need to identify where the threats are coming from, and so on. So absolutely same principle. Now, there is an added little, I should say, cherry on top of this, and that is the fact that now you've got, if we are to go with an open systems and use open AIs and everything, as to not belonging to a NEP, network equipment provider, then you've got to worry about other things. What is your root of trust, right? So 3GPP, ETC, NFV guys, right, this is one of the topics. What is the root of trust? Why would you define something to be the root of trust? Where shall I begin is a question. And that becomes more of a broader open question, more open we become.
Okay.
Yes.
Narendra, do you have anything to add on the cloud
Well,
services?
I'm actually quite happy that you're including cloud as a future network. In reality, I think Rakuten Symphony and Rakuten has been playing with cloud for almost 3-4 years now. So I think we have a lot of experience in building CNFs and trying to see how we secure it. As Mikko and Galina said, none of this is new, really.
Yeah.
I think what we're seeing is a blurring of line between telco and a typical cloud application, like any other financial or health or banking. So I think for us, we already have a set of industry best practices that cloud computing industry is already using. We just have to adopt them. And I'm also happy to say that Orion Alliance, unlike 3GPP, also builds specifications for OCloud, right? So in a way, it is standardizing the security measures that your open cloud has to follow. I think that will go a long way in helping Central and every other operators in the world to implement standardized security practices for OCloud. And I think that's probably it's a big win for us.
Okay. There's some very interesting comments here. What I'm going to do to close the session out is I'm going to just ask each of you for your closing comments, your key takeaways for security. So Galina, I'll start with you. What are the key takeaways for the future security of future networks?
Okay, my key, I have a lot, but let me just prioritize it in my brain here. So, yes, there was a question about 6G. Mm-hmm. Unfortunately, we're still in 2G in some parts of the world. And this is a discussion taking place in GSMA, fraud and security group, right? Yeah. So what do you do? Where absolutely no crypto is used whatsoever. And what happens with IMSI catchers and so on and so on. So bottom, to me, number one, is to actually do not forget about legacy. Mm-hmm. To me, this is number one. Why? Because you cannot simply say, cut off your 2G, 3G, 4G radio, become 5G today, as all MNOs have done investments that they've done. Yeah. So, yes. So hence, what must be done is fix the old problem. Why? Is because everything is interconnected. As we all know, these 2, 3, 4, 5 guys are all interconnected. So problem in one will cascade into an absolute, I would say logarithmically, into problems in other networks, including 6G. 6G is gonna make it worse, speed-wise, as we're talking about terahertz of radio, which hopefully would, translate into proper cores as well. And it's I'm picturing in my mind, literally, imagine the Matrix movie, right? So little bits surrounding us. Because even though with 5G we're talking about ultra low latency and densification of radio, 6G is gonna make it quadruple ultra, right? Some people claim that 6G is gonna make 5G look like 2G. But we shall see on that aspect. But again, I come back to your question, and that is, we must not forget about what we've got there now. We must secure properly. When I say properly, ZT, zero trust. You cannot afford to design networks of the future without embedding security into them. Multiple reasons for it. So one of the prime reasons is, as we're designing networks, we're designing for latency, low latency. How could we design low latency if we do not include all necessary elements? And security is a necessity, not a luxury.
Very, very, very informative. Mikko, your key takeaways.
Thanks, Sam. Firstly, I must say that it's wonderful to be sitting here with fellow actual security practitioners. we have always this look in the world that what could possibly go wrong. And I agree to that, and I'm also thinking it often. I do also like to think positively and seeing actually all the opportunity that comes when we are going on the latest technology and applying the lessons learned from previous generations. And I like to think that maybe if we faster deploy 5G, faster get services and people and societies running on it, actually it makes things a little bit better. Then one thing that I dislike in the security discussion around telecommunication, probably applies to many other areas also, is that there's this tendency for looking to have a silver bullet. And as far as I know, silver bullets were not invented yet.
Correct.
So,
I agree.
Exactly. So sometimes it is a certain standard or specification or single technology or a hype made out of a concept like Zero Trust architecture. It is a set of best practices we've known for 20 plus years.
Okay.
I agree fully. We are also deploying Zero Trust architecture to our portfolio, and that is one of the cases that ESM is providing, Zero Trust architecture visibility and monitoring. But we need to avoid silver bullet thinking.
Yes.
Our governments need to avoid thinking that there's one thing that can solve it all. As vendors, we need to be respectful and also understand that we need to communicate transparently that there's no silver bullet, holistic approach is needed, and we actually need to focus in every layer of that security stack. So my concerns going forward would be that I hope that as community, working together with the industry, with academia, with governments, that we actually find a way to learn from those mistakes so that we don't have to be talking about password management 2030 MWC.
Nagrendra.
Fully with you.
Great points, Mikko and Galina. I completely agree. Since we're talking about future networks, maybe I'll just mention a few things. I think it's the openness, cloudification, disaggregation, I think is here to stay, right? Whether we call it 6G, 5G advanced or 7G, I think that is going to be the baseline architecture for future.
Yeah.
And therefore, I think we all need to understand, and operators especially, and government regulators, as Mikko said, there is a huge skill scarcity amongst the operator community, amongst the regulators, and even in terms of culture, right? So I think there needs to be a lot of investment that goes into training, building the culture, and so on and so forth, right? I think that is very important. Of course, Huawei had a great presentation on the two most important technology enablers, AI and quantum. I'm not going to talk about that. What I do see, Mikko, is that in the future, as you rightly pointed out, there is no silver bullet. I think the focus is going to shift towards resiliency. And what I mean by that is, you cannot plug everything, right? It is going to happen. If an attack happens, how do you ensure that your network is resilient, is able to handle the attack, and stuff like that? And the tool that Senthil talked about, which is to help detect those kind of events, I think is very important. I think it's a step in the right direction. I do see a lot of focus going into security operations, because I think 50%, to me, blindly if I have to put a number, most of the issues happen during operations, right? I mean, all the issues happen during operations, but I don't know how much of budget we actually spend on that. So I think building a resilient network, I think is important. Of course, we have Zero Trust, we have, post-quantum, AI, all those beautiful enablers. I think the focus should move towards building resilient networks. I think that would be my thought process.
Interesting. Well, I'd like to thank all the panelists here today for contributing. So thank you very much, guys, for joining us. Thank you.